How come you're pointing away? Because I'm too loud. Are you?
Locomotion of fish.
Swimming is obviously a major part of the life of fish. Most fish swim with the rhythmic side-to-side motion of the body or tail. The rhythmic contractions are produced by bands of muscles called myomes running along the sides of the body. Muscles make up a large percentage of the body weight of a fish, as much as 75% in tunas and other active swimmers. Sharks tend to sink because they lack the buoyant swim bladder of most bony fish. The large amount of oil in the huge liver also provides buoyancy because it is less dense than water. Because most bony fish have a swim bladder, they do not have to rely on their pectoral fins to provide lift. Let's review.
Fish usually swim with sideways undulations of the body and tail. The pectoral fins and tail of sharks have an important role in buoyancy control. The fins and tail of bony fishes are generally not used to control buoyancy and instead have become highly maneuverable and important in swimming.
Such wonderful things around you. What more did you looking for?
Digestion.
After being swallowed, food passes through the pharynx in a short tube called the esophagus into the stomach. It is typically J-curved or elongated, but may be modified into a grinding structure or even lost altogether. The food passes from the stomach into the intestine. Other digestive enzymes are secreted by the inner walls of the intestine and the pancreas. Another organ important in the digestion is the liver, which secretes bile needed for the breakdown of fats. The intestines of cartilaginous fishes and a few primitive bony fishes contain a spiraling portion called the spiral valve, which increases the internal surface area of the intestine. The intestine is responsible for absorbing the nutrients resulting from digestion. Undigested material exits through the anus or the cloaca, the common passage for the digestive, excretory, and reproductive systems in the cartilaginous fishes.
Under the sea.
Great white sharks. Is there any sea beast so feared by humans? Great whites like these, here off the coast of South Africa, in an area called False Bay, can reach 20 feet in length and weigh up to 5,000 pounds. That's more than a pickup truck, but slightly less than a luxury SUV. Add this to the fact that great whites can sprint through the water at speeds up to 43 miles per hour, and it's no wonder we're afraid of sharks. But should we be? I mean, let's face it, they have great vision, they're curious like cats, and they love to taste things that get their attention. But many scientists believe they don't like to eat humans. They feel about humans the way most humans feel about lima beans. There's something to eat out of desperation. The fact is, great whites sometimes taste humans for the same reason they taste other things like motors or boats. Their ampullae of Lorenzini prompt them to taste it. Of course. The ampullae of Lorenzini are gel-filled electroreceptors found all around the shark's snout and head. That's these smaller pores you see here. These receptors are extremely sensitive to electrical discharges, even as small as 0.005 microvolts. That means anything that gives off the tiniest electrical charge has to be checked out, including all living creatures in the sea. Forget humans and motorboats. If you want to see what great white sharks flip over, literally, let's talk about seals. We know that some whale species engage in what's called breaching, leaping out of the water. But did you know great white sharks can breach as well? Look at these false bay great whites put on a show as they go after a seal decoy being pulled by a boat. If humans are lima beans to sharks, then seals are a double hot fudge ice cream sundae with 3 cherries on top. Luckily, we're, lima beans?